Good afternoon, class. I wanted to give you a video of today's lesson, just in case what you were taking notes on didn't quite make sense. We are working with isosceles. Right, isosceles. Spell it, triangles, and equilateral triangles. Equilateral triangles. Right, with a little bit of abbreviation there with the triangle symbol. I remember the definitions of these. With isosceles, you had at least, oops, 2 congruent sides. And then with equilateral triangles, you had 3 congruent sides. Which means, if you think about it, the equilateral triangle is not only equilateral, it is isosceles. Just to surprise you on that one. Let's go to the next slide and let's begin. First, properties of an isosceles triangle. Okay. Lots of things here. Congruent sides are considered to be the legs. The other side is its base. And then with the base, it has base angles. So formed with the base, are the angles, the base angles. Okay. Base does not mean bottom, and that's going to be the most commonly mixed up thing with isosceles triangles. So you might put a thing in your notes. Base does not equal bottom. Base is just the other side that are not part of the congruent side. So you've got a leg, and that means this side, this third side is the base. So base does not actually or always mean bottom. Something to remember or note. Your first theorem is the base angle theorem. If 2 sides of a triangle are congruent, then the sides opposite them are congruent. And remember, I always love this if-then, because you've got to meet these conditions. If, do I have 2 sides of a triangle congruent? Or sometimes drawing a picture like that. If you know 2 sides of a triangle are congruent, then you can include, right? You got angle A and angle B and angle C. That angle A is congruent to angle B. Okay? Being able to identify the conditions that need to be met to use deductive reasoning if 2 sides of the triangle are congruent. Then I can conclude the base angles, right, are congruent. I can use my symbols, or I can just say angle A is congruent to angle B. First example says find the measure of angle F. Well, I first identify my 2 congruent sides, and then it says the angles opposite them, right? So the angles opposite. So I've got GH, angle opposite is F, and I've got FG, opposite is H. So remember on 4.1 we talked about opposite sides. This is where it is totally critical. So we're able to say that angle F is, right, measured angle F is 65 degrees. Now an extension of that is, what is the measure of angle G, correct? How would we figure that out? We'd use the triangle sum theorem. So this is 65, right, 65, 65, right? We get 0, 130, so measure of angle G equals 180 minus 130 to give us 50 degrees, okay? 50 degrees. Now, there is a converse to this theorem, which means we swap the hypothesis and the conclusion. We leave the if and then. If 2 angles of a triangle are congruent, then the sides opposite them, right, are congruent. Now, did you notice the base angles did not need to be on the bottom? So, again, I like the if-then box. And I might just draw pictures. A, B, C. If I know that A and B are congruent, then I know I can conclude that AC, segment AC, is congruent to segment BC. With our example, right, they give us two elements out here, the 4x plus 4 and 32. Notice they don't have any degree symbol next to them, so they're not representing an angle. They're representing a side. So ST, the length of ST is 32, and the length of RT, right, equals 4x plus 4. The question is, can we solve for x? Well, let's find out. We know that angle S is congruent to angle R, so the sides opposite are congruent. So when two sides are congruent, I can say ST equals RT. So 32 equals 4x plus 4. And then I'll solve for x. Subtract 4 from both sides. Right? 28 equals 4x. X equals 7 once I divide both sides by 4. So let's double check. I plug in 7. 4 times 7 plus 4, that's 28 plus 4 is 32. They are in fact equal once you plug in that value of x. So again, remember, on these symbols, once that goes away, you notice it's y with the degree symbol. That indicates an angle on number 1. Since these sides, we know these angles are congruent, so y equals 50. Over on number 2, y does not have a degree symbol, and it's located in between, right, these two vertices. So y is a side length. These are my congruent angles, so my sides opposite are congruent, y equals 9. So these are pretty basic examples. Again, please note the difference between an angle measurement variable and one that represents the side. Here's theorem 4.5. This one has to do with equilateral triangles, okay? If a triangle is equilateral, then it's equiangular, right? So if I've got congruent sides, this should be an extension. I'm going to erase this right here. It should be an extension of the base angles theorem. If I've got congruent sides, my angles opposite them are congruent, right? Oh, and this side too. So the angle opposite them are congruent. So I've got equiangular. It's kind of a weird word. And then theorem 4.6 says, basically it's converse. If a triangle is equiangular, then it's equilateral. So again, the converse of the base angles theorem says if these angles are congruent, then my sides are opposite, or opposite sides are congruent. And then I got this third angle, and they're also congruent, so it becomes equilateral. Okay. So not too complex. It's just identifying the type of triangle. So if I've got this triangle, it's equiangular. I know that it's equilateral. So I know AC is equal to BC. So 6x plus 3 plus 7x minus 1. And then I solve for x. Minus 6x. It's x plus 1 plus 1x equals 4. So let's check. 6 times 4 plus 3, that's 24 plus 3. That should be 27. 7 times 4 minus 1, that's 28. Minus 1 equals 27. So we did find the correct value of x. Hopefully that helps you get familiar with the isosceles triangles and the equilateral triangles. With this caveat, remember, an isosceles triangle has at least two sets of sides, or two sides that are congruent, which means an equilateral triangle is in fact an isosceles triangle also. I hope that helps. Have a good night.